Hello, gentlemen and ladies, here's the Leader Dredger Knowledge class. I am glad you are watching this video. This knowledge class will start from the history of the dredger, including its application fields, characteristics, working methods, design, production volume, dredging depth, soil type, mud conveying distance, and dredging device, including 10 parts. The cutter suction dredger originated in the United States. In 1884, the first cutter suction dredger was used in Oakland, the western port of California, USA. Cutter suction dredgers are widely used in port, channel dredging, and hydraulic filling projects. The biggest advantage of using a cutter suction dredger is to obtain an accurate excavation profile. The cutter suction dredger is basically suitable for digging various types of soil. Of course, it also depends on the configuration of the cutting power. The cutter suction dredger has a wide range of types and sizes. The minimum power of the cutter head can be 20 kilowatt and the maximum can be about 4,000 kilowatt. However, the dredging depth is generally limited, and the minimum depth generally depends on the draft of the hull front. The cutter suction dredger is a static dredger. There are at least 2 mooring systems that are important to the excavation process. But the anchor cable has brought obstacles to the navigation of other ships. Some large cutter suction dredgers are equipped with a propeller system to reduce the risk of being snagged. The propeller system can be used to help the cutter suction dredger to leave the excavation area, and of course, it can also help cutter suction dredging. The ship moves from one working point to another. The small and medium-sized cutter suction dredger can be made detachable. This method is more suitable for transportation from road to inland area without waterway. The characteristics of the cutter suction dredger are: it is a static dredger, and the cutter head is installed as a digging tool to make the soil sucked after cutting. In the process of sucking mud, the cutter suction dredger rotates in a circular arc through the anchor cable fixed on the side winch with the positioning pile as the center, as shown in the figure. The reamer support arm is suspended on the support arm support, and the reamer head, driver and suction pipe are all placed on it. For small and medium-sized cutter suction dredgers, A-type supports are generally used, while for large cutter suction dredgers, the supports are generally larger and heavier. Because part of the cutting force needs to be balanced by flat-bottomed boats and positioning piles, the flat-bottomed hull of a cutter suction dredger is heavier than other stationary dredgers. The excavated mud-water mixture is transported to the mud dump by hydraulic suction pipe. However, some cutter suction dredgers are equipped with barge unloading systems. The cutter suction dredger is equipped with one or more dredger pumps, one of which is placed on the cutter arm. The propeller device of the self-propelled cutter suction dredger can be placed at the front of the dredger near the cutter head, or at the rear of the dredger near the positioning pile. After the cutter arm of the cutter suction dredger is put into the water, the dredge pump starts to work and the cutter head starts to rotate. The initial movement of the dredger around the positioning pile is accomplished by relaxing the right anchor cable and tightening the left wrong cable. When designing a cutter suction dredger, important parameters include: 1. Production volume, 2. Dredging depth, 3. Working conditions that affect the size of the dredger. 4. Soil type. Cutter suction dredger is suitable for digging various types of soil, from clay to hard rock. The type of soil has a great influence on the design and construction of cutter suction dredgers. 5. Dredging distance. The cutter suction dredger is suitable for digging and bending all types of soil, from clay to hard rock. Type of soil versus cutter suction dredger. Design and construction have a great influence. When digging a rock for hundreds of hours, considerable reaction forces are generated. These forces are generated by the cutter head through the cutter arm, and the side winches are passed to the land or overcome by punts and piles. The design of the cutter suction dredger is also determined by the required cutting power. When designing a cutter suction dredger, it is necessary to consider the maximum and minimum dredging depth, because these affect the availability of the dredger. When the dredging depth increases, large, resulting in a deeper draft of the punt, which will increase the minimum dredging depth. In this way, increased dredging depth can increase the availability of dredgers. Of course, the production volume is determined by the market and the dredgers that can be used for the specific project. From the perspective of production volume, in order to obtain the required output, the suction depth determines whether an underwater pump is required. Another economic problem with underwater pumps is that underwater pumps are generally very expensive. Market demand determines the best choice. The type of soil has a great influence on the power of the cutter head, the length of the cutter arm, the design of the punt, and the steel pile. To some extent, the soil type also affects the selection of the diameter of the suction pipe and the hydraulic pipe. The mud transport distance is related to the power of the mud pump and whether a barge is needed to transport mud. When the mud conveying distance is too large and the use of hydraulic mud pipes is not economical, a barge is required. It may also obstruct navigation and do not need to use mud pipes. Cutter suction dredgers rarely use barges to transport mud. If the cutter suction dredger is equipped with an underwater pump, the factor to be considered when selecting the power of the underwater pump is that only this pump is working when the barge is loaded. When designing the cutter suction dredger, the following factors should be considered. 1. The power of the cutter head. 2. The power of the side winches. 3. The axial cutting force. 4. The vertical cutting force. 5. The power of the JIB winches. 6. The engine. 7. The mud pump. 8. The mud pump driving. 9. The water pump. 10. The water pump 1. The positioning and loading system.
Thank you very much for watching, and we will meet again next time.